Hey, my name's Tess and today I'll be measuring the pH of different substances found around the home. The measuring of pH is one of the most, if not the most, prevalent experiments done in laboratories. This is because pH is such a vital part of chemical and biological phenomena. pH is used to find chemical characteristics of different substances. It is needed when performing or determining chemical reactions, and all living organisms and the survival of organisms rely on pH. So, as you can see, it is extremely important in biochemistry. To measure the pH of the different substances in today's experiment, I'm going to use a red cabbage as the pH indicator. But before we get started on the experiment, I will explain the science and biochemical concepts behind the different parts of this experiment. Firstly, the P in pH stands for power and H is the symbol for hydrogen. So this is all about how hydrogen reacts in an aqueous solution. In an aqueous solution, there is an equilibrium between the water, which is H2O, the acid, H+, and the base, OH-, which can be seen in this diagram. However, when an aqueous solution contains other substances such as acids or bases, the hydrogen ions can shift and make the concentration increase or decrease of these hydrogen ions. So as the concentration of H+ increases, the concentration of OH- decreases. Acids increase the H+ in a solution, while bases decrease the H+. This makes acids proton donors, which can be seen in this formula, and bases proton acceptors, which can be seen in this formula. So you might be asking how we can use a red cabbage to determine the pH of these different substances. Red cabbage contains anthocyanin, which is a water-soluble pigment that changes colour when it is mixed with an acid or a base. Anthocyanin is found in many fruits and vegetables as well as flowers. Taking all this into account, we can begin the experiment. I'm going to have more than one hypothesis to make things a bit more interesting. Hypothesis 1. Red cabbage can be used as a pH indicator. Hypothesis 2. The most acidic solution found in my home is bleach. And hypothesis 3, the most basic solution found in my home is ammonia. For this experiment, we need 7 clear glasses or containers. Today I'm using a blender. We obviously need a red cabbage, a strainer, and a large bowl. And then we need the acids or bases found around the house. So today I'm using lemon, bicarb soda, bleach, ammonia, soda water, and dishwashing detergent. Also, because this experiment is positively controlled, I don't want anything to interfere with the pH levels in the different containers. So we're using distilled water to get our pH, to mix with our pH indicator of the red cabbage, to try and have as much validity of this experiment as possible. Also, obviously, when conducting any experiment in the home or the lab, we need safety precautions. So today I'm wearing gloves, an old shirt to protect my skin, glasses to protect my eyes. Always make sure, girls or boys with long hair, that you have it tied up, and always wear enclosed shoes. Okay, so to start with, we're going to pour some distilled water into the blender. If I was doing this experiment in a laboratory, I would definitely heat the water over a Bunsen burner and put the red cabbage leaves in there whole to get the dye out of. But because I'm doing this at home today, and it's much quicker and I guess a little bit easier to put it in the blender, so that's why I'm doing it this way. But yeah, definitely the better way would be to heat it over a Bunsen burner. So put the water in, the cabbage, and then blend it. Okay, the next step in this experiment is to pour the mixture we've made, the pH indicator of the red cabbage and the water, through a strainer just to get out any chunks of cabbage and into a large bowl. So I just transferred the pH indicator into something with a beak or a lip so it's easier to pour into the containers. Okay, so now we just pour a little bit of each of our solutions that we've found around the house into a container, obviously each one in a separate one. So I'm quickly going to do that. Okay, now I'm going to pour the red cabbage indicator into each thing and see what colour it turns. Okay, so I was expecting the bleach to be an acid, but as it turns out, it is actually a really strong base. So I quickly made up a new solution with white vinegar and a pH indicator. So that's this one. So lucky I had some white vinegar in the house. So now I'm going to put them in order of strongest acid down this end to strongest base down this end using the pH indicator chart for red cabbage. See that the lemon juice is red. I'd say the white vinegar is in between red and light pink. The soda water is dark pink and close to purple. The pH indicator is obviously in between blue and purple because it has a pH of 7, or it should. The detergent it's really dark purple, so I'd say it's in between, it's closer to blue, but again, it's not completely 8 on the pH indicator scale. The bicarb solution is definitely blue, and it is turning a bit aqua, so maybe 8, 8.5. The ammonia is green, definitely, and so it's 12. And the bleach is really dark green, so I'd say it's nearly at the yellow, so maybe 13. Okay, so what exactly is happening in the solutions when we pour the pH indicator into them? So this is the chemical formula for the citric acid, so the lemon juice, which was actually the most acidic item we found in our house. So I'm sure there are more acidic items found in the house, but out of the ones that we used, lemon juice was the most acidic. So this is what's happening. So this is the citric acid, and when it's combined with the water, it, as mentioned before, it's donating its protons. So the extra protons, hydrogen protons, go to the water, and it loses it from the citric acid, and that's in equilibrium, so it's constantly moving back and forth. And in the bases, we've got this one for ammonia, and as you can see with the ammonia, it accepts the protons, so we have, it turns into NH4 plus and OH minus, and again it's in equilibrium, it's constantly moving, and yeah, constantly sharing the hydrogen ions. Okay, so I'm pretty sure we can get each of the solutions back to the original colour of the pH indicator. So what we're going to do is we're going to go 2 out from the pH indicator, which remember has a pH of 7. So we're going to go 2 out, we're going to use the bicarb soda solution and the white vinegar solution. So they are about even on the pH scale out from 7. So I've already prepared the bicarb soda solution, and now I'm going to mix some of the pH indicator into it, and it should give us that lovely blue colour. There we go. Okay, and now I'm going to pour some vinegar in, and that should turn it back to the original colour of the purple. And there we go. It's turned back to the purple. So you dispose of all of these carefully, and definitely don't drink them. And yeah, the quicker you can dispose of them, the less of a health risk it's going to be. So I'm going to get to that now. To improve this experiment, if I was to do it again, I would use a stronger filter to filter out more of the cabbage pulp out of the pH indicator, and I would also measure each solution and make sure the exact same amount of each solution was poured in with the pH indicator, just to get a better sense of the colours, and just to make it a bit more accurate. So with this experiment, we saw that only one of the hypotheses was correct, in that the red cabbage can be used as a pH indicator. The second hypothesis, that the strongest acid in the house would be bleach, was proven wrong, as it was actually a base. And the third hypothesis, that ammonia would be the strongest base in the house, was proven wrong as well, because it's actually, the bleach was the strongest base. This experiment showed us what were the strong acids and bases in the house, and this can be useful to determine, what you're eating, to know the pH in foods that you're eating, and also just to be careful around those products that are strong bases or strong acids. And yeah, it's just fun to know, what bases and acids are in your house. So I hope you enjoyed this experiment. Thank you.